Hello friends, so in this video I will talk about how to create the Feynman diagrams using the root framework. So let's first go to the root terminal. So type root minus L, then I will open the T browser, new T browser. Then I can go to the new T canvas, file, new T canvas, on which I will draw the Feynman diagram. So let's first extend it, and also here I can extend a bit. Okay, now then you can open view editor, which basically provide the option for the edit, and then you can also open the toolbar, which basically allows you to draw the Feynman diagram. So I will first try to draw the Feynman diagram for the Baba scattering, which is basically E plus, E minus, electron and positron scattering. So let's first write on this terminal, on this basically canvas, Baba scattering. For this you can use the latex option. So you first select the latex and then you click here, and then you hit the enter from the keyboard. Then you will get the option to write the text string. So I will write Baba and then scattering, and I will select the color for this also as a blue. Okay, now I can draw the Feynman diagram. So for that we need the lines and the mediator particle. This is basically gluon or photons. In this case is photon. So first select the line. So you just draw a line, and then you can choose the width is 2, and then I can basically clone it, draw clone. And it allows you to clone it, so you can rotate it line by selecting it as normally we do in the editor. Now you can move it here, and I can basically look at the distances. No, okay, no, okay. Now we can also put the mediating particles. In this case it is photons, but we don't have the option for the photon. So first we have to select the gluon, then we can convert into the photon. So let's select it here, and then we move. This first will become the gluon, and then you can also choose several options here. So let's first make the width as 2. Okay, now we want to convert this gluon to photon. So this provides the option to the select. When you select it, then it will become the gamma. So now you can see it's become a gamma, and you can also choose the wavelength. For example, smaller wavelength, and you have multiple wavelengths, and then you can also choose the amplitude, for example, yeah. So these all things you can basically modify from here, and then you want to produce the same line here, so we can copy this line, draw clone. Okay, and then it will produce the clone, and we can insert it here at the same point, and we can also copy this line, draw clone. Okay, so now basically it completes the Feynman diagram, but we have to put the particle name and also the arrow. So for the putting the particle name, we can again use the latex option. So let's first select the latex, and then we hit the here, and then we hit the enter. Then we can write E plus. Okay, and then we can basically clone it, draw clone, and we can select the different color for these particles again as we did it. So E plus, and then you can again clone it, draw clone, basically copy, and we can move it here, E minus, and then we can again clone it, draw clone, no, not draw class, it's I think mistake, draw clone. Okay, and then we can move it here. Now we can further make one more thing. we can basically save this whole view as a C++ code, and then you can basically fix minor differences. For example, here if you just zoom it, here there's a differences, so these smaller differences you can fix in the code, which is basically saved in the .c macro. So file save as, and then you can save it in the code .c macro. So Feynman and .c. So since we already saved the macro Feynman.c, so now I can look at this macro, what is inside this macro. So then you can see this is the macro. We have a canvas, and then we line for the particles, and then this is for the mediator photons, curly line. So these all things. Now what you can do here, for example, I will explain here. So to create the Feynman, so if you run this code, it will create the same diagram. So now since you don't have the common vertex point here, so these small differences you can fix inside this code. Basically you have to put the proper coordinates so that they intersect at one point. So for example, this coordinate you can make it equal. So these are xy coordinate for the line, and then the mediator. So these all things you can fix in the code once you create this Feynman diagram. So there is still one more thing remaining here. I need to put the arrows. So first, for that we just go to view editor, and then we can add the arrow also. So one arrow I have to add in this direction. So two arrow we need in this direction for this and this one. So I created one. Next we can clone it, draw clone. So I need two arrows. So one arrow I will add here, okay, and another arrow I will add here, okay. And then what I can do, I also need this arrow in this direction also, okay, and then I can clone it, draw clone, okay. So I created the two arrow this direction, and then I can rotate it, okay, and I can create this arrow here also, okay. So what you can do here now, now we want to arrow in different format, we can also make that. So first you click here, now your arrow option is activated. So then you can basically select different styles. So this style is very famous, so you can see it, and then we can select it also here, this arrow, and then we can select this option, okay, and we can select this option also here, this arrow, and we can choose this option, and then we can also select this arrow, and then we can put this option. Now we can again create the code, C++ code, basically root code for this geometry, this basically Feynman diagram. So then you can just save it, Feynman with arrow, Feynman diagram with arrow .c. So it will create a new the C++ code for this basically diagram. So let's save it, okay. No, I did a wrong thing. Feynman diagram arrow.c, okay, it's already created C++ code. So then I can open it, okay, gedit Feynman diagram, and then we can choose the arrow, and then I can run it also, root -l Feynman diagram arrow. So it's already, it can already create the Feynman diagram. So if you see this diagram, there's a minor fix, you will need it. So since your vertex is not intersecting at one point, so this minor fix you can do in the code. basically you have to put the same coordinate, and this also you can fix it, and this minor angle differences you can fix in the code. So it's very simple. You have to put the proper angle of this line, and then it will basically fix all the Feynman diagram. And then you can also create this high resolution. For example, you can save this EPS images, which is basically high resolution by scattering. For example, arrow. Let's save with this name, arrow version, and then okay, and then so you can see that it is very high resolution, high quality picture. So once you fix these minor differences in the code, then you will get a very high resolution picture for the Feynman diagram. So then you can create multiple pictures also here. For example, I will show here also. So this is for one Feynman diagram. If you want to create another Feynman diagram, for example, you want to create another one, so you can also do that, and then you can create corresponding code, and we can fix the differences, minor differences there. So for example, I can do it here, and then I can do the glue on vertices. Okay, and you can also select the wavelength here. For example, if I want to make more fine, or we can do more coarse, these all things you can do it here. You can see it's already there, and then you can again also choose this curly if you want to choose it like this, and then you can clone it, draw clone. Okay, okay, and you can basically clone these also, draw clone, and you can move it here, and you can draw clone it also, draw clone. You can copy it, and minor fixes you can do in the macro once you create it. So these all diagrams you can easily draw in the root framework, and then it provides very high quality images. So this is all. Thank you very much.